Hello and welcome to this latest Walking Talking mock. In this video we're going to be taking a look at the 2024 paper for Unit 1 of the OCR Computer Science GCSE series. These are the topics that will be covered in your Unit 1 exam. You need to make sure when you go into that next May you're confident in terms of all of the content listed on this slide. As always, we're going to take a look through how you can get 80 out of 80 or a grade 9 with the shortest, most obvious answers possible. It'd be really useful if you had a blank copy of the paper. That one isn't available yet as I record this via the OCR website, but if you've got a teacher, your teacher will be able to log in and access the paper on your behalf. I would suggest that you then attempt each question before flicking on to the correct answer that I talk you through. Okay, let's get started. So, question 1 starts with some binary conversion, and it's looking for binary to denary conversion. Now, this is one that for the most part you're either going to know how to do or not. I would really recommend this is a skill you revise the day before your exam. This comes up every single year. You will absolutely get marks for this, and if you don't know how to do it, you are absolutely going to drop marks. That is the answer there. There are multiple different techniques for converting between binary and denary, so I won't go through those, but there are videos on this channel talking through how to convert between different types of numbers. 240 and 30 are the denary values, and then you've got the binary value of 0, 1, 1, 0, 1, 0, 0, 1 as your denary outcome. You've then been asked to complete the table by writing the answer to each statement. Now these again are very linked to binary numbers. If you know your binary numbers and how they work, you should be able to figure out all of these answers. The smallest denary number that can be made is 0. Amazing how often students put 1 there. Remember, 0 is absolutely a number. The largest denary number that can be made by only 6 bits is 63. Maximum number of different colours that can be represented with 7 bits, it's 128. And the minimum number of bits needed to represent 150 different characters in a character set is 8. 7 would be 128, so it needs to be one binary number higher than that. Binary division and multiplication didn't come up very often in this particular year, which to me makes me think that could come up in the 2025 exam, but it's asked you for a left shift of the binary number. We need to move the number to the left 4 times, and any time we end up with a blank gap then we enter a 0. So we should have 4 1s and 4 zeros as our first answer, as our final answer, sorry, on that first page of the exam. Moving on, we're then asked to look at some hexadecimal. Again, hexadecimal is something that comes up pretty often in the exam, and you need to better know how to convert between hex, binary, and denary. Again, there are different techniques for this one, but this asks you to explain how it's done using an example. So you've got a couple of different areas you can gain marks for this question. The way I would do that is to convert each hex digit into a 4-bit binary nibble, then join those binary nibbles together and then convert those to denary. It does though say you need an example, so 4F for example, the 4 would become 4 in binary, or 0, 1, 0, 0. The F would become 15 in binary, which would be 1, 1, 1, 1. Join those together, then do the conversion just as you learnt how to do on the previous page, and that would become 79. So 4F is used to represent the denary number 79. Again, if that's not a topic you're familiar with, really do recommend revising that one. The next question asks you to do some binary addition, and really important to note that there are marks available within this one for your workings. So if we add a 1 and a 1 together, for example, we put a 0 and we carry a 1. That carrying of the 1 is really important. Remember, a 0 and a 0 is a 0. A 0 and a 1 is a 1. A 1 and a 1 is a 1 carried and a 0 in the current column, and 3 ones would then be a 1 with a 1 carried over. So I get a mark there for my answer, which is 0, 1, 1, 1, 1, 0, 1, 0, and I get a second mark for carrying over the 4 zeros. The next question, I must say, is a really, really mean one, and one that surprised me a little bit when I first saw this exam paper. IP addresses have come up a number of times, but this is the first time they've asked for an example that I can remember of an IP6 address. And I must say, IP6 addresses are a little bit confusing. So IP4 addresses are made up of 4 chunks of numbers between 0 and 255 separated by a dot. So 192.168.0.1 is a very popular IP address because it's utilized by lots of routers as their IP address. So you would think that IP6 means, right, we're going to have 6 lots of numbers, when in actual fact it's 8 lots of numbers. And with the 8 numbers, it also becomes 4 digits. Okay, so this one does get quite a lot more confusing in terms of our answer. As I say, that's one you're either going to know or not know, and it is one very worth revising, although it is the first time I've seen a question of that type come up in the exam. The next one is even harsher again, and it's asking you to describe the format of a MAC address. So IP addresses change from network to network. A MAC address, though, is assigned to your network access card. Now, that's not what the question is asking. The question is asking, what format does a MAC address take? It is 6 groups of numbers. Each group of numbers is 2 digits of hex, and each group is separated by a full stop or a colon. Now, that is quite confusing because you would think 6 groups of numbers, right, that's IP6. That's not how it is. MAC addresses are hexadecimal, 6 hexadecimal strings, and each string is 2 digits in length. Again, a harsh question there, but I think one you'll either know the answer to or not. Worth noting, the grade boundaries for this paper were a little bit lower than in previous years. The next question is all around exam technique. It asks you to describe 2 benefits to the airport of using wired connections in their network. So, it's asking you to identify what are the benefits of wired connections, but also link those to definitive benefits to the airport. So, faster connection. This means reduced queues at check-in because the computers can transmit the data more quickly. You could even expand that again and really link that into the airport. What does that mean? Well, potentially I can hire fewer staff. It's also more secure, and that means that passenger data is less likely to be intercepted. Be careful there in saying it's impossible to get intercepted. It's certainly not impossible, but it is most definitely harder. That's one where you've got to read the question. That's all about exam technique. It wants you to know the benefits, but also link those into this make-believe airport. The next one says, explain the reasons why the airport should allow wireless connections to be used in addition to the wired connection. It's 3 marks, so that suggests it's looking for 3 separate points. It allows a much larger number of devices to connect. So a networking switch, for example, might only have 16 ports, whereas a wireless router can connect, 255 wireless devices easily. It allows users to move around while connected, and it could be a backup if the wired connection fails. So there you need to think, why might we want both types of connection at this make-believe airport? We're now asked to draw a star topology. So you've been given a number of devices that need to connect into this network, and we've been asked for a star topology. In a star topology, the switch is at the center of the network, and all of the other devices branch off of that switch. You could have a printer connected to a PC, but for me, a strict star network should look like this. What you shouldn't have is any wires connecting the PCs to other PCs. That then becomes a partial mesh network. We're then asked to give a benefit of this approach. This approach is really good because there's significantly fewer cables and that lowers the cost. But the switch is absolutely vital. If the switch were to break, the whole network would go down and none of the devices could connect to each other. We're then asked to describe the role of the switch in the topology. What does the switch do? Well, it connects the devices together, it receives data from all the devices, and it also directs data on then to the correct destination. Remember, a switch is different to a router. A switch has got nothing to do with connecting to the internet, and therefore if you reference the internet in your answer, don't. That would be for a router. Also worth noting with questions like this, you'll see that I'm bullet pointing my answer. I'm making it really clear to the examiner that I am making 3 definitive different points, and therefore giving them 3 opportunities to give me the marks I'm after. So we've moved on to a new question now, and that normally means a different set of topics will be assessed. This is looking at the operating system and the sorts of utility software that might run within a Windows-based PC. We've been given some functionality, and we've been asked to name those using the names given in the specification for this course. So memory management is the thing or the term for the function that moves data from secondary storage to RAM. Peripheral management is all about allowing connections with other input and output devices, keyboards, mice, printers, scanners, webcams, that sort of thing. File management is the feature that allows us to create, name and delete folders. And finally, the user interface, and that's about allowing the user to interact with the computer hardware or to provide, for example, a graphical user interface for us to click on. We've then got a fill-in-the-gap question. These are becoming more and more popular. The Computer Science GCSE has had quite a lot of stick for being one of the most harshly marked GCSEs on offer, and therefore they're trying to create questions that all students can have a really good go at. Therefore, I think the fill-in-the-gap questions and the fill in this box or draw an arrow between these 2 answers type questions will be used more and more often. In this example, encryption is the software that uses a key. If the data is intercepted, it cannot be understood. That finishes the first sort of section. It then moves on to defragmentation software. Defragmentation moves files into consecutive areas of the storage, and it makes access of the data faster. You wouldn't in that last one get speed, and that's what a lot of students put this year was speed of the data faster. It should be accessing the data that is quicker. You've then got the essay question. Now the essay question is the question you know will absolutely come up in your exam. You will all have an essay. You will all have to think outside of the box. You will have to give your opinion on something. Often that's to do with advances in AI and ethics and things like that. But this year they focused in on software licenses, proprietary and open source software. I'm not going to form this as sets of paragraphs, but you really should. I'm not going to because I think it makes it much harder for you to read. There, though, are a range of different points that I think you should bring up. It says it wants you to outline the features, so you need to better talk through what is open source and what does proprietary mean. It then asks for the legal and ethical issues for each license, and I've listed those there. You'll need to finish with the benefits and drawbacks of each, so use the points I've made to give the benefits and drawbacks, and it also in the question says it wants you to make a recommendation. Now there's no wrong answer there, so everyone should be able to give this a go. Open source will probably mean that more people can play the game, people can add their own features, maybe add different plugins for the game, they can find bugs and help fix them. But proprietary means the programmer will make money. They can perhaps provide better support and invest in improving the game in the future. There's no wrong answer there. Everyone should be getting 6 out of 8 on the essay question. We've then moved on to binary representation, and sound or images will always come up in the exam. This year they focused in on sound. I'd therefore bet really good money that images will come up next year. That'll be May 2025. That's not to say that sound won't. Often they do ask about both. But for me, I think images would be very, very worth revising for next year's exam. A musician uses a computer to make and record music. Tick the box then for the correct answer. Well, the correct answer is the amplitude of the wave is measured at set intervals. That is, I'm afraid, the only correct answer. And if you've ticked more than one, you wouldn't get any marks, even if that was one of the two that you had ticked. It then asks you to explain how changing the bit depth will affect the sound file. Really important to note, it hasn't said that the change is to increase the bit depth or decrease. So your answer should be along the lines of the number of bits per sample will change. That means the quality will change and the file size will change. But we're not particularly tied into whether that's higher or lower. You're next asked to outline whether magnetic or secondary storage would be better for this computer. You can get the marks for either one, as long as you can justify your answer, but you need to give a really solid justification linked to this musician. I've gone for solid state. Very fast gets me my first mark, but I need to say the impact that will have on the musician. All of the 4-mark questions you see, you need to use a connective. This means that. This happens, and therefore this occurs. So it's very fast, meaning no delays in saving the songs. It's also silent, meaning there's no noise interrupting the recordings. That connective, that meaning that, in my answers is really important every time there is a 4-mark question. It then asks for any other type of secondary storage, and the only one remaining is optical. Optical is things like CDs and DVDs. We've already been given magnetic, we were already given secondary, so that's got to be the answer to this question. They've then jumped back to a little bit more binary in terms of file sizes and units of storage. It's asked you firstly to convert or to work out the smallest one, and the way I would do that is to convert them all most likely to megabytes. I think that probably leaves your maths the easiest. To go from megabytes to gigabytes, it's all around adding 3 zeros or removing 3 zeros, depending on which way we're going. And the answer should be that 200,000 kilobytes is the smallest unit of capacity. We're then asked to convert 3 megabytes, but 1,000 songs into gigabytes. That should be really straightforward maths. It's 3 megabytes times 1,000 songs, but because we want it in gigabytes, we then divide by 1,000, and therefore the answer is just 3. If you times by 1,000 and then divide by 1,000, we can ignore all of that. 2 marks there, 1 for the working and 1 for the answer. We're then looking at the fetch, decode, execute cycle and the von Neumann architecture in terms of our registers. It asks you to describe what happens during the fetch execute cycle. Now, it isn't enough to just say things are fetched, things are executed. Its data and instructions are fetched from primary storage. You could say RAM, you could say registers, you could say cache. The best answer, though, is primary storage. That means all of those things. Data and instructions are decoded. You might talk about the fact that happens in the control unit. And instructions are then executed. And normally that execution will be the arithmetic and logic unit if there's maths involved. There's only 2 marks there, so you only need 2 of those 3, but it made sense to give all 3 of the prime answers for that question. You've then got 5 registers you can pick from, and it just wants you to name any 2 of them and what they are used for in the FDE cycle. I've gone for the program counter. That keeps track of which instruction we're on by storing the address of the next instruction, and the accumulator, and that stores the running total or the result of all of the calculations that have happened so far. This next question is really harsh because it's a really easy question, but the mark scheme is horribly hard. If you've said cache, you haven't got a mark. If you've said cause, you haven't got a mark, or even just the word clock and you haven't got a mark. It's got to be clock speed, the number of cores, and cache size. I must say, I do think they were really unfair with this question on the mark scheme. When it talks about those characteristics, remember the 3 C's: cause, cache, clock. But you must call those clock speed, the number of cores, and the cache size when you move into an exam scenario. I think this is probably then the final page, question 7, and they like to finish with some questions around embedded systems. So there's a new follow me system, and that's going to be a cruise control for a car. And the first thing it asks you to do is explain, why is that an embedded system? It's an embedded system because it's a CPU built within a larger device. It's got one or very limited functions, and the software can't be changed or can't be changed easily. Those are always going to be your 3 points for an embedded system: CPU in a larger device, limited functionality, and the software can't be changed. It then asks you about the ROM, the read-only memory for the system. Now that's a little bit different for a embedded system. We've got the startup instructions, which is the same across all computers, but also the firmware or the operating system. Now normally that would be held within the secondary storage, but one of the things that make embedded systems embedded is that we don't really have any secondary storage. Everything really is going to be stored within the ROM. So that idea of the firmware or the operating system would be the correct answer. We're then asked 3 items that would be stored within the RAM. Remember, the RAM is all about what's currently happening, the currently running instructions. Again, we've got to be a little bit specific though with our phrasing. It's the speed of the vehicle in front, and the distance between the 2 cars. E.g., if I'm in a car that's going 80 and the other car's also going 80 and there's 100 meters between us, that's probably okay. But if I'm going 80 and they're going 10 miles an hour, then there's clearly going to be an issue there. So it's speed of your vehicle, speed of the other vehicle, the vehicle in front, and the distance from the car in front. The final question says, explain why we don't need virtual memory. Virtual memory is around moving items from the RAM to the secondary storage to fill up space in the RAM. Well, embedded systems use very limited RAM. We also can't install new applications or change the code, and therefore it's very unlikely the RAM would ever run out. Okay, that's going to be your final answer to get you full marks on this paper. I hope that's been a useful run through of the May 2024 paper. Research says that past papers are the absolute best way of revising, but only if you use mark schemes or videos like this one to help check your understanding. That really is very important. If you do have any questions, please post those into the comments section below. Thank you very much for watching.